It is now time for our biology class, and I hope you are here and ready to learn. Now, happy Corona season. As you can see, I'm meeting the Corona hairdo, and I hope your Corona look is as lovely as mine. Now, we're going to be looking at transport today and the need for transport. Let's go ahead and pray before we begin. Heavenly Father, we invite your presence to guide and protect us through this class session, and that you will bring wisdom, you will bring knowledge, you will bring understanding, and you will help us to utilize this knowledge and this wisdom so that we may be able to have it for time and for eternity. Now, our transport system, all organisms as well as everybody needs a transport system, and we are going to be looking at transport system in both animals as well as in plants. Now, this is for this class where I'm going to expect you to know a few things. Explain why multicellular organisms require transport system. Explain why plants require transport system for water. State the name of the movement of water through a plant. State the structure involved in transport of water in plants. Describe the structure and function of xylem. Describe the function of guard cells. I'm going to ask you as well to know or name the environmental factors which increase the rate of transpiration in plants, as well as explain why plants require a transport system for sugar. And the last thing I would expect you to learn from this class session is to state the structure involved in the transport of sugar in plants. Alright, so we are going to be starting our class off as to why organisms need a transport system. Now we know that we have single cellular organisms and we have multicellular organisms. Now multicellular organisms are organisms with many cells. We did these already, and hopefully you are remembering as we're talking. Single cellular organisms are made up of only one cell. And you know some examples of that. You can go ahead and say them: the amoeba, the bacteria, the fungi, the viruses. All of these are single cellular organisms. Now, why do multicellular organisms rather need a transport system? Now, if you look at your PowerPoint presentation that you should have in your possession, we are looking at a table, and this table is showing us the surface area versus the ratio, versus volume ratio rather. Now, if an organism is small, a cube, 1 centimeter cube, it has a surface area of 1 centimeter square, then the surface area to the volume ratio will be very small, and it will be leaning in the direction of the surface area. So it will have 6 faces, so it will have a lot more space around it rather than the volume inside it. Now we're going to be looking at our examples that we have. I'm going to use two household things to explain what it is and how organisms require a transport system. We're looking at a small tomato and a little bigger tomato. Now if I were supposed to get something to try to penetrate this small tomato, it would be much easier for me to penetrate this small tomato rather than penetrate this bigger sized tomato. Same thing occurs if you are cooking. If I were to need 10 pounds of flour and I put all that 10 pounds of flour in the pot, just make one big dumpling, it is going to be much more difficult for me to cook that one big dumpling rather than making smaller dumplings and cook those smaller dumplings. So it is the same effect that smaller organisms compared to larger organisms have. If we are not going to be able to supply all the things that we need if we are multicellular organisms by us getting it from the environment that is around us. So I couldn't get my oxygen through my skin because I have too much volume on the inside for oxygen to penetrate. So these are some things that you need to know. The larger the organism, the smaller its surface area to volume ratio. The larger the organism, larger organisms need transport systems to carry raw materials. Now, we're going to be starting our look at plants and transport. Now we're going to think a little bit. Tell me, what needs to be transported inside of plants? You can go ahead and state them. And if you have stated water, if you have stated nutrients, and if you have stated food and waste, these are all things that need to be transported in plants. Now, the part of the plant that transports one thing specifically, water, is the xylem vessel. And this is going to give us an idea of what the xylem vessel is like. Now, the xylem vessel, it's made up of mostly dead cells, and the xylem vessel contains, the cells contain no content, nothing much is in the cell. It has no nucleus because they are dead cells. The end walls have broken down and degenerated. The side walls are strengthened by lignin to prevent damage by water pressure. Right? So this is what the xylem vessel is like. Now, if you are now willing to look at your PowerPoint presentation, you are going to be naming or labeling a diagram. Now we see here, this looks like a plant root, and it is getting some water from the soil. Now we see the water in the soil particle, and we are also looking at this part, which is the hair root or the root hair cell. And then we are going to name that part, which is the lignin, which was when we mentioned earlier, and you saw it on the previous slide. And there is the xylem vessel, which is the whole thing. So that is how the transport begins in plants. Now, plants need water for photosynthesis, and it is absorbed in the root and evaporated out of the leaves. And this is called transpiration. Now, transpiration, wherein the root takes up the water is absorbed in the root, and it is carried up through the stem, through to the leaves, and it evaporates from the leaf. This is called transpiration, and it is very vital, especially for the water cycle. Now, transpiration rate is affected by different things. Now, the rate of transpiration is affected by several things such as light, temperature, humidity, wind. Now, light, if there is a lot of light, that means the leaves will be open and ready for photosynthesis. Therefore, the pores in the leaves will be open, and the water will leave the leaf readily. Temperature, the hotter the time is, the more water will be lost by the plant. So humidity means that there is a lot of water in the surrounding. If you have ever been in the building when the rain just fell outside and the sun came back out, it becomes very humid. The time is very hot, but there's a lot of moisture in the environment, and you feel very sticky. That is what humidity is. So that also affects the rate of transpiration. Wind also affects transpiration. Now, how do we measure the rate of transpiration? Transpiration is measured by a potometer. Now, this measures how much water moves along a tube. Now, if we change the conditions around the potometer, the change will begin in the transpiration rate. Now, what I have for you to do is I want for you to think of a way that you can try to find a way to measure transpiration rate. Now, the structure of the leaf, you're going to be looking at the structure of the leaf, and we're going to specifically look at the guard cell. And you are going to be labeling all of these lovely parts of the leaf: the cuticle, which is the upper layer, the upper epidermis, we have the lower epidermis, and we have the stoma, which where the guard cells surround the leaves. Now, we are going to be looking at the function of the leaf, as well as all of the areas that